Good afternoon, everyone. This is Chelsea Torres from ICEA. I'm sure many of you have been to our webinars before, but for those who are new, the webinar will last about 45 minutes and we will open at the end for questions. So if you have any questions during the webinar, please use the chat box to send them. And when we reach the Q&A portion, I'll send you a message asking if your question was already answered. Or if you still need to ask it, I will unmute you so you can ask yourself. Today's webinar was one of many presentations that were scheduled for our San Antonio workshop. This and all the distance learning series webinars this summer will count as 1 hour of training or 0.1 points towards your CCEA recertification. So please keep your confirmation email in your records for that when you apply for recertification. Here to present using predictive analytics and open source data to estimate cloud infrastructure costs for government IT systems are Kara Cooley and Amanda Ferrero from Price Systems. Ladies?
All right, thanks, Chelsea. I just wanted, as you can see, Amanda and I will be talking today, but Rich May also from Price also put in a huge effort, and Dan Harper as well Dan Harper from MITRE gave us some of the models that we use to compare our results to. So the purpose of today's presentation is just to give a brief overview of some cloud infrastructure and let you know why we did this research and what our goals were with the scope and implementation, and then go over what we actually did, including how we gathered the data, what the data consisted of. Our two models that we'll be talking about are CERs for virtual machines and benchmark models for some storage, and how we validated and compared them to some models that Dan Harper from MITRE gave us. All right, so just to go over what cloud is and some of the issues with it. As we all know, federal agencies are moving to the cloud, and they're using commercial cloud services or commercial cloud companies to do that. And now more than ever, now that we're doing a lot of remote work, that's one of the reasons why cloud is very important. And we need to come up with some lifecycle cost estimates for IT budgets for all the types of cloud services there are. There are some federal agencies out there that have developed tools to estimate cloud-related costs for providers. The one I want to point out is two folks from the CAG. Last year, anybody who has attended the IT cast might be familiar with their presentation on Amazon prices for virtual machines. But we have to be able to predict things sometimes years in advance, and the cloud service provider might not be known by then, or the company or the federal government might be thinking of moving to a different provider, and budgeting is a lengthy and complex process. In addition, the pricing structures and the terms that the major providers use is slightly inconsistent. So to come up with something standardized was our goal, something we call vendor agnostic, that we use data from multiple vendors and the types of pricing that they have, and we would try to standardize their pricing structures across all of the different providers using open source data that we could find on the internet. So again, we wanted to come up with some, at least some cloud lifecycle costs estimates, and to help budget ahead of time. So just to go over a little bit of the scope. So this is more for business IT systems because this is commercially available cloud data that we could find again on the internet. So no DISA pricing. There's no private cloud prices on here. Our focus was virtual machine and storage prices. And we had over 28,000 pricing data points from 6 providers. And this is part of ongoing research that we've been trying to do on cloud transition and operations costs. As a little overview on what a virtual machine is and what it interacts with, and so as you can see, virtual machine here, it's usually a server of some sort, like a blade server, and it's made of CPUs, which, do the basic computing tasks, and memory, which stores the data. And that can be connected to some temporary memory, some local memory, that this memory goes away when the virtual machine gets cut off or when it gets turned off. And it's a cost that's usually included in the virtual machine price. Now, this isn't always here, and there isn't always local storage. And the virtual machine and the local storage can be connected to long-term storage, which it doesn't go away once the virtual machine gets turned off. This is always an add-on cost. And this can include snapshots, which is a type of backup to preserve the virtual machine instance at a certain point in time from the temporary disk. And it can include other data too. So the three types of data, in addition, is object data, which is unstructured and it has metadata, and it's usually accessed using an API. File type of storage is like your typical file explorer. It's organized in folders, a folder hierarchy for easy organization, and then block storage, which is fixed blocks size of storage, and these are all separate pieces of data. So the block storage includes the local disks that virtual machines are attached to. So these are the different pricing structures that we kept in mind when we were coming up with our models in CERs. So format 1 is just a plain virtual machine without any storage, any local storage attached to it, any long-term storage. But you can get the basic disk storage attached to it. I'm sorry, this is representative of non-local storage. But then you can have a combination of all the different types of storage that you can attach to the virtual machine as well. And that's demonstrated in formats 3 through 5. You can get, a virtual machine with the temporary block storage attached to it and any additional storage that is persistent. So let me talk about the data for both the virtual machine and the storage models. So again, this is open source, non-proprietary data that we collected about 28,000. So about 27,000 of those were Linux virtual machine instances. There were about 17 government rates in there just from one provider. So we did not feel comfortable separating that into a different model. We are doing an update to the models. We just started collecting data last week, and from what I'm seeing, I have found more government rates, so that we could try to split that out, but we'll have to see how many data points we have. And then there's about 1,600 storage data points from 6 major vendors. So as you can see, mostly these are government approved. Alibaba is, I don't think the federal government is, I really don't think the federal government is using Alibaba, but we wanted to keep all the data that we could. And we just collected the data from these sites. So this Bonsai Cloud website was a great source of, it had a centralized database of, I think 5 out of the 6 providers. And then we got some additional data from an Amazon. It's not affiliated with Amazon, but there was a special website that somebody was collecting Amazon data from. And then there was, we collected IBM data from IBM Cloud's pricing website itself. Okay, so with the data collection, we obviously, like any data collection and analysis project, we had to normalize the data. So we did little things like converting GIB to gigabytes, which is just a special You can see the conversion factor in the bottom right corner, and some of the pricing structures. Some of the data was text, I believe bandwidth, which is, rate of data transfer was text, and, we tried to assign some numerical factors when we were doing the analysis. And the data collection, while a lot of it could be automated, there was some manual data collection. We used web scraping when we could to easily collect data, but that wasn't always possible. And then we had to do some additional matching using Excel. And there was some data that either due to time constraints we couldn't gather or we couldn't try to normalize. Most notably is graphic processing units, GPUs, which handles, as it says, dealing with graphics, which would probably be a cost driver, but we didn't have time to normalize that data. But when we did develop our normalization process and collect all the data, these are the categories that we had for the virtual machines. The major ones, CPUs, the RAM, obviously the name up at the top. The local disk was included, so that extra local storage, how many gigabytes was that, was included that. There are different hourly prices. So on demand is a pay-as-you-go, but then there's contract prices called reserved. So we looked at 1 and 3 years, which is typical across all the providers. And then the location, which was important because our models ended up looking at US prices only, so we did throw some data out from other continents. Similarly, with the additional storage, we wanted the name, but the more important things were the storage type, and because that's how we came up with our benchmark models. The type, if it was disk type of storage, the type of disk, solid state drives, which are flash memory versus hard disk drives, based off of which stores memory in a physical capacity on a disk. We thought those were important distinctions to make in the data. And then the prices we normalized. Sometimes they were monthly, most of the time, I believe it was dollars per gigabyte per month. And then again, location. I'll go over the virtual machine CER models, and then Amanda will talk to the storage. So again, we filtered on the United States locations. We were looking at virtual machines with more than 0 CPUs, memory. There were some outliers in the pricing data that we just took out. You can look at the paper for a better sense of how we honed in on the data to get this distribution. As you can see, we have about 6,400 data points when all is said and done. And as you can see, it's very skewed. We saw that it had a log normal fit. So once we did the log transform, I just have these statistics here to demonstrate that it's way closer to a normal distribution, but you can see that in this snapshot here once we did the log transformation. So then that's how we approached our correlation as well, to look at the relationship between the log normally transformed variables. As you can see here in the regular database, in the original database, there was a strong relationship between the price and the memory. These are Pearson's R values, and not a strong relationship between price and CPUs. But when we did the log transform, the price had a stronger correlation with the memory and the CPUs. But there was some concern about the memory and the CPUs having correlation as well. So there, like I said, there are some concerns about collinearity, but we decided to move forward with the multivariate regression because we felt that even though it was on the border of having trouble with collinearity, a lot of the pricing models, pricing calculators out there are a function of the memory and the CPUs. This just walks through what the regression looked like. So in the beginning, we had the original data set, and when we did the log-log transformation on both, when we did the log-normal transformation on both sides, as you can see, the fit looks a lot better with memory, with price being a function of memory and CPUs. However, the user can't do anything with log normal price, so we have to bring it back into unit space by taking the exponent on both sides. So these are what the final models look like. Now, again, we had the 3 different types of pricing, and we also had models that, we saw that local disk space was a driver as well of price, so that we split up the models based on that, on those 2 key factors, the pricing type and if there was a local disk in the virtual machine. So in the top portion, there's the 6,400 data points, and then when we looked at the local, just data points with the local disk, that was about 1,100 data points. And as you can see, the local disk data points do have the better R². That's something to keep in mind when I talk about validation. But so again, these are the CERs that we came up with for the virtual machine pricing. And Amanda will talk to the storage.
Okay, so like Kara said, part 3 of this approach is developing the additional storage pricing models. And you can see the note at the bottom, all the storage prices we used are standard rates. So first up, there's 3 different types of storage. The first one I'm going to talk about is object storage. Within object storage, there are 2 different calculation methods. The first one being a rule of thumb calculation. This is where the total monthly object storage price is just the rough estimation of 1 terabyte multiplied by the number of terabytes. The other method is a detailed price calculation method. This is just when it is a sum of the total storage price, the transfer price, and the monthly request price, all summed together separately so that it's a little bit more detailed, more specific to the pricing that the user finds. This table here shows the average prices in each category for each of the 6 providers that we researched. All of the prices listed here are averages across the regions throughout the US. Like Kara mentioned, we only looked at the US for time reasons, so all of these prices are averaged across all the US regions per provider. The operational requests down here, they include write and read requests, and the prices are per 10,000 operations. This table here just focuses on the average rates. It's the same table as before, it's just more of a focus. This is just showing the vendor agnostic prices. So these are the values that we used in the model. So it's the average across all 6 providers to get our vendor agnostic prices. Again, these are the values that are used in the model. The next type of storage is block storage. This includes snapshots and disk storage. So there's 2 different types of disks, HDD and SSD. The prices here across the 6 providers were averaged together for each disk type. And these are the prices that you see here. And the snapshot model is the same thing. The price was averaged across all the providers and all the regions in the US, and these final values are what is used in the model. The third type is file storage. There's two types of pricing here, a performance type and a capacity type. Performance is when you pay as you go, and capacity is paying for a set amount of storage ahead of time. So depending on which you choose could save money, depending on what your preference is. Each of the providers uses a different preference here. The table, you can see which one they all use, the prices that they have. These prices are dollars per terabyte per month. And this average monthly rate here at the bottom is the average across all 6 providers, whether they were using performance type or capacity type. We just averaged all the prices together, and this 255.32 is the value that is used in our model for file storage per terabyte per month. Now Kara is going to talk about the validation and the model comparison.
Thanks, Amanda. So with the process of how we did this, we wanted to compare the CER estimates for 100 random instances from the database to determine if what we would get using our CER versus the actual is significant. So we wanted to use, absolute average percent error and Pearson's R to make a comparison. And then we also were able to get a hold of some models from some federal agencies and compare our CER estimates and storage models to that. We wanted to see if we were within the same range. So this is just a little diagram to demonstrate what we did. So again, we wanted to compare our vendor agnostic CERs to the federal models. When we looked at the random subset of our original data set, our results were marginally acceptable. Typically, the CPU, the virtual machine and storage CER performed significantly better than just the standard virtual machine CER. So the 3-year discount rate tended to do better than the 1-year discount rate. And as you can see, the Rs, they didn't trend that well together. For the regular virtual machine results, when you had local disk storage, it trended a little closer in terms of the R squared. I think I spoke to all these points, that when you have the local storage, they trended better. And the 3-year discount rate was better than the 1-year discount rate. And we're within about 20 to 30% plus or minus for overall error. And I didn't want to go in depth on our agency model comparison because, we recognized after we did that there could have been some issues with it, such as we didn't always have a lot of context with those. We generally knew what they were trying to price out in those calculators, but we didn't always know. We don't know what fiscal year they got their data from. And so in conclusion, the average comparisons and validations were about 30%. In the future, we plan on just stratifying the data into a training and test set. Since we have, thousands of data points, there's really no reason not to do that. So future versions of this model will have that validation built into the process for the virtual machines. We're still trying to figure out how we would better validate our storage models. So in summary, we did come up with 2 models to estimate cloud storage costs. The virtual machine, which is made up of CPUs and memory, and the additional storage. And we do have a database that can help a user pick a specific price, or if they want to filter the data on their own, to come up with CERs and models based on their specific needs. If they want to make a CER that's vendor specific, they can. That's the beauty of having an open source database. Some Future plans we have are to come up with some backup cost methodologies, also to come up with some default recommendations for our virtual machine CERs. That should say CERs, not calculator. As I mentioned before, we are updating the pricing right now and coming up with better ways to validate our CERs. And of course, we need to come up with some we need to come up with some more lifecycle cloud costs. So transition costs, any type of maintenance costs that might be associated with cloud services. Unfortunately, there doesn't seem to be a lot of data out there. So if anybody has any suggestions or data out there, that'd be great. We would appreciate that. And if anybody wants to reach out to me, that's my email. And again, we just want to thank Dan Harper for giving us some input and some of the early data and some of the validation models that we used. Are there any questions? I know that I think Chelsea just wrote that there's no questions so far.
Yeah, if anyone has any questions, I'll unmute you so you can ask yourself. All right, so I am not seeing any questions. You can contact Kara, or you could contact the ICEA office if you have any questions in the future about this presentation.
Yeah, I just want to say there was a paper that we wrote that accompanies this, and it's pretty thorough. So if you want to check out the paper that that's out there, that should be on the ICEA website, right, Chelsea?
Yeah, I'll post this on the distance learning web page if you want to send over your updated, if you made any updates, but it'll be on there.
Okay, great. Yeah, we haven't made any updates to the paper.
Okay, cool. So Kara and Amanda sent this as a paper for the workshop. So a reminder that the 2021 call for papers is now open and you can submit your abstract on our website. Please also don't forget to join us for next week's presentation, Storytelling for Cost Estimators by Christina Snyder. If you have any questions, again, please reach out to us at ICEA, and you see Kara's contact information up on the screen. Great job, Kara and Amanda. Thank you both again for presenting today. Take care, everyone, and we'll see you next time.
Thank you. Have a good day and holiday, everyone.